Students, in this section, operations with radical expressions, we're going to simplify radical expressions and then add, subtract, multiply, and divide them. But in this video, we are just going to focus on this one right here, simplifying radical expressions. So you can multiply radicals with the same n, so the same index. Okay, you can multiply them, you can put them together. The square root of 2 times the square root of 8 is the square root of 16. You can put whatever inside your radical together. So that's just what this property is saying. Same is true for dividing radicals. Again, if they have the same n, if you will, you can separate them like this, or you can put them together as well. So the square root of 27 over the square root of 3 is the square root of 9, which is 3. Same thing here. The cube root of x to the 6 over x to the 8th. You can go ahead and simplify that on top and on bottom. So that's what we're going to practice in this video, is simplifying these radical expressions. So what we have here is the square root of 32 x to the 8th. Let's go ahead and split this up. We have the square root of 32 and the square root of x to the 8th. Square root of 32, is there a perfect square that goes into it? 16 and 2. So we're going to go ahead and take that square root of 16 on the outside. So we have 4 square roots of 2. And then the square root of x to the 8th. Remember, we can write it as x to the 8th to the 1/2. And that would be x to the 4th power. So now we're going to put these together. We'll leave our radicals at the end, so it's 4x to the 4th square root of 2. That would be your final answer. All right. Okay, let's look at this next one. And I'm going to give myself some more room. You might want to give yourself some room too as I explain this. All right, so the 4th root of 16, the 4th root of a to the 24th, and the 4th root of b to the 13th. So the 4th root of 16, that's going to be 2, and you can do that on your calculator if you didn't know that. The 4th root of a to the 24th, that's going to be a to the 6th. Now the 4th root of b to the 13th, that gets a little tricky. So what we want to do is we want to find something that, a power, I guess, that 4 goes into. So it's the 4th root, it comes out nicely. So I guess you could say a perfect 4th, if you will, instead of a perfect square like we said over here. A perfect 4th, so something that 4 goes into is 12. So we could split b to the 13th up to b to the 12th and b to the 1st. And keep in mind, we're doing the 4th root of these. And I'm not leaving myself enough room. That's a 4. So the 4th root of b to the 12th is b to the 3rd. And the 4th root of b to the 1st, can we simplify that at all? No, so we're going to leave that as the 4th root of b. So let's see, what can we combine here? What's going to be on the outside? 2 is going to be on the outside, a to the 6th, and b to the 3rd. So 2a to the 6th, b to the 3rd, and then we have the 4th root of b. And that would be our answer. So whatever your n out here, you want to kind of split your exponent up into what your n can go into. And remember, when you're multiplying, that means you're adding the exponent. So I could split this up into 12 and 1 because that adds up to 13. And 12 is divisible by 4. So that comes out nicely to b to the 3rd. Alrighty. This is going to come easier with lots of practice. So I have lots of examples here. Alright, here's some with dividing. And I'm actually going to change this to a y because I typed it wrong. So that's a y there. No reason, I'm just typed the problem in wrong. Okay, so using our quotient property, we're going to go ahead and take, I'll use a different color as well. We're going to take the square root of x to the 6th over the square root of x to the 7th. Square root of x to the 6th, that comes out nice. That's going to be x to the 3rd. Now, keep in mind our even, even, odd rule. We have an even here, even, even, odd, so this has to be in absolute value bars. That was from last section. All right, and now we have the square root of x to the 7th. Let's go ahead and simplify that up. So what's something that 2 can go into where we can split this up? The highest, I guess, number, if we split up x to the 7th. Right, 6. So I would split this up into x to the 6th. And it's not x. Dang it. Sorry, guys. It's y. What am I doing? My mind is on x. What the heck? Okay, so it's y to the 6th and y. And again, we're taking the square root of that. So the square root of y to the 6th is y to the 3rd. And we're left with the square root of y. Now, what's wrong with this answer? Right, I cannot have a square root inside the denominator. So how do I get this square root out of the denominator? I'm going to multiply by the square root of y over the square root of y. Now I can do that because, remember my exponents, they're adding up to whatever my n is right here. So y times y is y squared. The square root of y squared is just y. So that's going to simplify down to y. We'll have enough room here. So we have y to the 3rd times y in my denominator. And that's going to simplify down to y to the 4th in my denominator. And up here, what am I going to have up here? Can we combine any of these? Nope. So it's just going to be x to the 3rd in absolute value bars times the square root of y. All right. So rewind if you need to watch that again. All right. And come with lots of questions. But again, this video, I'm doing lots and lots of practice here. Okay, the next one, we have the square root of 5a to the 5th over b to the 13th. So I'm going to go ahead and split it up just like I did on the last one, top and bottom. Square root of 5a to the 5th over square root of b to the 13th. So that's going to end up being the square root of 5. I'm going to deal with the numerator first, times the square root of a to the 5th. So the square root of 5, I can't split that up. There's not a perfect square that goes into 5, so I have to leave it like that. Now what about a to the 5th? Is there a perfect square? Something that 2 goes into, an exponent that 2 would go into, the highest one that goes into a to the 5th. A to the 4th, you bet. Let's try that. So again, I'm taking the square root of both of those. So we end up with, this is going to be a squared, and then we have the square root of a. We can't split that up any farther. So my numerator, I'm just dealing with my numerator here. My numerator is going to be, we still have this guy, the square root of 5, and the square root of a. Let's put those together. So my numerator is going to be a squared times 5, the square root of 5a. All right, so that's my numerator. I'm going to save this for later for when I'm going to simplify things. Now let's do my denominator. Okay, the square root of b to the 13th. Well, what can I split this up into? Some perfect squares here. We have this is the square root, so there's a 2 out here. So what can 2 go into that I can split this up into? Right, b to the 12th. And then we have b. So we have square root of b to the 12th and square root of b. Square root of b to the 12th is b to the 6th. And then we have the square root of b. And hold on one second here. Okay. So now this is my denominator and this is my numerator. So now let's simplify this because we cannot have a square root in the denominator. I'll try to make my b's look more like b's here, not 6's. So we're going to go ahead and we're going to times by the square root of b over the square root of b. We can go ahead and put these together. The square root of b times the square root of b is b. So that's going to be b to the 6th times b on the bottom. So that's going to be b to the 7th. And we can go ahead and put these together because they're under the same radical. So my numerator is going to be a squared times the square root of 5ab. There we go. All right, one more example. All right, now we're dealing with the fourth root of 6 over 5x. So let's go ahead and split this up. I'm going to go ahead and give myself lots of room here. So we have the fourth root of 6 over the fourth root of 5x. And all right. So we can't take the fourth root of 6. Nothing that's a perfect fourth root goes into 6, and nothing that has a perfect fourth root goes into 5x. So we have to get rid of this radical in the denominator. So we have to make this a perfect fourth root. So right now we have 5 to the first, so how can I make that, what can I multiply by to get that 5 to the fourth? Right, 5 to the third. And then x to the 1. How do I make that be perfect x to the fourth? It'd be x to the third. So I'm going to multiply by the fourth root of 5 to the third, x to the third, on top and on bottom. So let's simplify the denominator first. So we have the fourth root of 5 to the fourth and x to the fourth, because we can combine these because they're under the same radical. They both have the same n, which ends up being just 5 to the fourth to the fourth root of 5 to the fourth, which is just 5, and the fourth root of x to the fourth, which is just x. And then here we can combine these. So 5 to the third is 125. So 125 times 6 is going to be 750. And I'll show that work there, 125 there. And then it looks like we're going to have x to the third. Can't combine that with anything, so that's going to be the fourth root of 750 x to the third, because we can't simplify that any farther, so we're just going to leave it as is, and that is our final answer. So rewatch this video plenty of times, lots of stuff going on here, and come with questions in class. All right, see you later.